maybe YouTube is gonna work soon. It's saying sending data, but it doesn't actually seem to work. Got the one viewer, which is Rio. Hello. I love you. You gonna... Hello. Oh, that's cute. You tuned in. I think YouTube stream is working as well now. Yeah, it is. You're doing great, my love. Thank you. Yeah, YouTube didn't work last time. I don't actually know how to get to the chats. I mean, it's here, but don't actually know how. Yeah. That's the YouTube chat now. Okay. Both now. Cool. Hello, 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 and to everyone watching the VOD. So Rio is going to tune out in a second because what I'm about to do is going to be really boring. But anyways, I wanted to jump in. How did you know? I know you. It's boring. It's boring stuff. Boring stuff. You don't want to be here. It's boring for you, I guess. Your job is much cooler. So enjoy. Oh right, you're leaving already. Okay. One sec. Doing a couple of bits as well. Mwah. Bye. Have a good evening. Oh, sorry. I know you guys can't see anything right now. I'm just trying to go on Discord, and I don't want to dox anyone. Oh, I really would love a link to the stream. Nope, that's the wrong one. Here, yeah. Here, yeah. And we are going. Okay. Welcome everyone. This is my second live stream, and we're going to be doing some Rust stuff. We're going to be doing Rust traits, which means last time we finished in chapter 4, which means we should be actually going. Yeah, we should go on to number 10, but first, let's speedrun 5 and 6. So using structs to related data, and so I just kind of want to know learn the syntax. It's nothing too complicated. So let's go cargo. What is it? Cargo new structs. Okay, so we have structs main. There. I'll leave the file tree on because it gives a nice buffer to the right. Alright. Cool. We have print line. Okay, so we define structs using struct. Oh, what's going on there? Struct user. Active bool and separated by commas, right? And you can have username string. Yeah, stuff like that. Pretty cool. Oh yeah, we got the warning on that code. Okay. And we can create a struct like so. Let's just, yeah, okay, let's do email as a string. Sign in count is going to be U64. Oh, what is that? The fields are never used. Yeah. Oh, it's cool, it can do that. Okay, so we got the string, which is a module, and the from, space the from there. Oh, that's Discord. Sup? Hey, Rohit on YouTube. How are you doing? Cool. Actually quit Discord. Guess I dox another conversation. Alright, we have this stuff. And we have a couple of methods actually by default. Converts this type into the usually inferred input. Borrow, immutable borrows from an own slice. Type ID, try into borrow mutex. Mutable even. That's OBS. Let's go up here. Okay. Yep. If we let it mute, we can change that. What else is there? We can return using the fields initializing. Oh yeah, you can do the same things you can in JS. Cool. Create instance from other instance using the struct update. So we have that. Oh, you can have a spread. Using struct update syntax, we can achieve the same effect with less code. Using the dots specifies the remaining fields, not especially set, should have the same value as the field given. Okay, spread syntax. Using tuple structs without named fields. Cool, that's nice, handy. Unit-like structs without any fields. You can also define structs that don't have any fields. They are called unit-like structs because they behave similar to bracket, the unit type that we mentioned in the tuple section. Okay. Okay, ownership of struct data. This might be important. In the user struct definition, we use the owned string type rather than the pointer to a string slice type. This is a deliberate choice because we want each instance of the struct to own all the data it has. That makes sense. So for example, it's also possible for structs to store references to data owned by something else, but to do so requires the use of lifetimes, a Rust feature that we'll discuss in chapter 10. It's possible for structs to store references to data owned by something else. Okay, I thought you could always do this. Oh, but for structs to own them. Cool. So if you have well, it's because it's not compiled, it's because it's not produced desired behavior. So yeah, expected name lifetime parameter. Okay, so it really needs a lifetime there. Okay, you gotta learn about that later. Can't have a pointer if it doesn't have a lifetime defined. Method syntax. Actually, yeah, I mean, this looks pretty standard. What is this? Derived debug. It's interesting. Rust does not include functionality to print out debugging information, but we have to explicitly opt to make that functionality available for the struct. Okay. Oh, this, yeah. Interesting. Nice. It's kind of cool. Derived debug. Okay. Oh, and you can, yeah, cool. You can like do debug set here. That's a nice little trick. I'll copy that in. See what, actually, let's see what happens. CD stress cargo run. It's unused, sure, but it gives me rect1 equals rectangle with width 60 and 50. Nice, nice, nice. How are we doing on streams? in YouTube we have 2 people watching. Hello everyone. On Twitch we have 2. Alright, pretty nice. Hey guys. Hey everyone. Just doing a bit of Rust. Still pretty new to it, so any help is appreciated. Okay. So I think I'm pretty happy with this. This seems pretty straightforward. Enums and pattern matching. Okay, we can do enums like this. Oh, and the namespace, it seems. Yeah. Nice. We have IP address. The kind is an IP address. We can create IP address v4 or IP address v6. Nice. Okay, we can say it's. However, representing the same concept using just an enum is more concise. Rather than enum inside a struct, we can put data directly inside the enum variant. Okay. Yeah, that's pretty nice. v4 represents a string, and I guess you could put anything in here. You could put struct inside the enum, whatever you want, or this. Yeah, that's pretty nice. We've shown different ways to find the data, blah blah blah. However, as it turns out, wanting to store IP addresses and encode which kind they are is so common that the standard library has a definition we can use. Let's look at how the standard library defines IP address. It has the exact enum variants that we've described and used, but it embeds the addresses inside the variants in the form of 2 different structs. So it has those 2 structs. The code illustrates that you can put any kind of data inside, so like a struct, yeah. Let's look at another example. So we have a message, a quit message, a move with X and Y, a write to the string, and change color with hex values, I assume. Pretty cool. The 4 enums has 4 variants. Defining an enum with variants such as the ones in those listed. The following structs all the same data. Yeah, I mean we could have the unit and all this type of stuff, or we could just store it in the enum. It's quite nice. There's no more speciality between enums, so we can implement. Here's a method called call that we could define on our own message. So implement message. Let's take a look at this. This is it's kind of like starting to look at the things I wanted to look at. So if you had like this here, right? So if you do, let's move that back. So we implement a message method and implementation. We call, and we can do let m is equal to message.write. Hello. Okay, and then the call, the reason it has the call is because it's defined up here. And so implement some functionality for a type. Yeah. So yeah, it goes implement the type, what you actually want to implement, and if it takes in self, point it to self, it just means it's namespaced. Okay. And then message. So maybe this isn't actually a namespace. I misunderstood it a bit. It's a method, a trait actually. Could be defined here. Nice. Okay. The option enum is advantage over null values. Yeah, I've seen this type of stuff a bit before. Oh yeah, now we're getting into generics. We can have an enum for options here. Sum5, sum e, option equal none. So none is null. Okay. So if we have an i8 of 5 and an option of i8 which is equal to sum5, what happens? An implementation of i8 plus option i8. Wait. Okay. Intense. In effect, this error message means that Rust doesn't understand how to add an i8 and an option i8 because they're different types. When we have a value of a type like i8 in Rust, the compiler will ensure that we always have a valid value. We can proceed comfortably without having to check for null before using that value. Only when you have an option i8 for whatever type value you're working on do we have to worry about this. In other words, you have to convert an option T to T before you can perform T operations, which is, yeah, nice. The nullability checks on nullability is nice. Eliminating the list of incorrect, assuming a not null value helps you be more confident. Yep, it's true. Still didn't really answer the question as to why this can't be used. Oh, yeah, with a plus. Yeah, we can't plus an option. Right, you have to check. Yeah, that makes sense now. All right, I like it. The match control flow. Yeah, so you can match on enums. Pretty cool. Anything on chat? Nothing on chat. Yeah, feel free to say anything, ask anything. Any help, any tips? Yeah, pretty nice. Yeah, cool. I think I feel pretty confident with this, to be honest. It seems pretty straightforward, and then this is one of the nicer patterns, stuff like this, where you can take in an option and return an option. Yeah, matches are exhaustive. Yeah, this is a very good feature. Compiler doesn't compile if it's not exhaustive. Match 3, 7 or other. Yep. Or the underscore. Pretty nice. Okay. Yep. We're not going to worry too much about that. I kind of want to go and skip into generic types, traits, and lifetimes. Actually, is there a Rustlings project for this? Let's try this. Rustlings.cool. Love that. The book, Rust by example, getting started. This will also install cargo and stuff. Alright, is then yay Rustlings. Small exercise to get you reading and writing Rust code. Okay, let's install that. What happened there? Cannot find the debuggated binary required for some source files. What? Okay. Let's just download it with curl. Oh yeah, it's downloading all the source code and a bunch of other stuff. All the packages and all packages. Very reminiscent of JavaScript right now. Okay. Rustlings. Wait. How the hell do you use this? So we do curl. Yep. And the exercise sorted by topic can be found in the subdirectory. Task is simple. Why isn't it working? Rustlings. It's kind of weird. Can I just do not to you, / install. Hopefully we can try and reinstall. I mean, all this stuff is here already, so it shouldn't be too bad. Okay. Oh, please check that you have this in your path. Add to Oh, what's the fish command to that? Fish shall add to path. Fish add path. Dot cargo slash the binaries there. That's it. And then Rustlings. There we go. Thank you for installing Rust. It's your first time. We are going to teach you a lot about Rust. There's a couple notes. The central concept behind Rustlings is that you solve exercises. These exercises usually have some sort of syntax error in them. Okay. Okay. So let's get started. Rustlings watch, not watch. Here. Okay. Zoom in a bit. Yeah. Okay. You can keep working on the size jump. I am done. What if you want to use Rustlings? Make sure your editor is set up. Yep. Okay. You can keep working on this. What am I doing? Help. How do I? Let's go hint. Remove the I am done comment. Oh. CD Rustlings source exercises. Wait. Oh, it's there twice. You can get rid of that one, I think. Tests. Don't understand. What am I meant to do? Actually, let's put you over here. Alright, hold on. Bit confused. What am I meant to do? See the Rustlings. See the exercises. See the intro. The intro 1.rs. Okay, got you. Okay. Okay. Let's remove that. What else do I want? Hello. Oh, it wants the other one. Okay. Intro 2. Here's hello. I mean, okay. I think we can actually just go back into here. Okay, let's speedrun. Cannot find variable, so we need to do a let. Variables 2. Okay. You can keep running this exercise. Remove it. The I am not done. Actually, okay, so it needs a type. Do I need to put it 10? Accessory around variables 1. Execute Rustlings hint. Not sure what you want, to be fair. 3. You need to be initialized. There. Wait, you can keep working this exercise. Is it because I didn't remove this? Where is this? Our variable is 4. Let's remove you. You need to be not mutable, but not there. Variables 5. Don't change this line. Spell a number. 3 number. Oh. Expected string found integer. don't rename this variable. Oh, do I have to shadow? Is it shadowing it once? Yeah, shadowing. Ooh, yeah. Rust constants. I can't actually remember. Ah, they need to be typed. Let's go with usize. Call_me. Okay. Let's close all of these functions. 1, 2, 3, 4, 5. Okay. Let's go with 1. We can just do a function call_me. Let's go see previous 5 here, num u32, see previous, call me 0 dot num I in there. It needs to be like, I don't know, 10. See previous 10 goes here to UR. What's wrong with the LSP? Something's going wrong with the LSP. I think it's just borked because of like some sort of cargo project here. This needs to be, it returns now 32, or is it like this? Yeah, like that. It returns a boolean. And then before. Okay. Oh, wait, hold on. Which one is this? Oh no. Here. You're in the wrong place. What's going on, bro? Something really weird happening to my editor right now. Let's go V here. Functions 5. There we are. Nope. Nope. It's really weird what the hell is happening. Okay, so we have the statement, we gotta remove that. What, is this not the syntax? Is it like this? No. One of, so what needs, that can't be, oh, is that right? Like this? Okay. If 1, 2, 3. Let's put those here. Okay. Don't mind this for now. Capture CFG. Okay, let's go to that. Yeah. Give these functions return the bigger number. Do not use another function, this one variable. So just if A bigger than B, return A. We can just do A, B. What's wrong with that? Is it, you need brackets? Unnecessary parentheses. Yeah. I mean, I can do return, but I thought the expression was enough. Step 1, make compile, get the bar for foos and default to bar tests passing. Fizz, foo, else. Can I do this? I'm not done. If it's fizz, oh, literally anything baz. Else if fizzish is equal to fuzz, returns bar, otherwise baz. Yeah, I'm not sure about these implicit returns, but anyways, let's do returns everywhere here. Cool. Yeah, I mean, it's working here. Oh yeah, let's just do return. Oh wait, actually. Okay. Let the identifier, if it's a crab. Okay, beach crab. Gopher. Burrow. So okay, that checks out. So is it just get rid of this type of stuff? Okay. Oh, this is like the exit return of the if statement, not of the entire function. I understand. Okay. Let's continue cracking through. 1, 2, 3. This is a quiz for the following sections. Variable functions if Mary's buying apples, the price of an apple calculations following apple costs 2 rust bucks. If Mary buys more than 40 apples, each apple only costs 1. Okay. No hints this time. Yep. So apple underscore number. Let's go with a U32 and returns A32 for price. Let's say if apple underscore num is bigger than 20, no, more than 40, so more than 40, return apple underscore num, otherwise return apple underscore num times 2. Nice. Yep, we're going. This is the quiz for the following: strings, vectors, remove semantics, modules, enums. Let's build a little machine in the form of a function. Okay. As input, we're going to give a list of strings and commands. These commands determine what action is going to be applied to the string. It can either be, okay, uppercase the string, trim the string, append bar to the end of the string. The exact form of this will be the input is going to be a vector of 2 linked tuple. The first element is the string, second one is the command. Yep. Okay. Complete the function. So the input is going to be tuple of string and string. It's going to return the modified string. I think it's vec. Oh wait, what's the output? Give you a list, blah blah. The output element is going to be a vector of strings. Sure, why not? Take string command in input iterator. Let's return the output. Oh, it's all right, it's a match. match on the command, and the command is actually the enum command. God, I can't remember. Upper. Okay, let's go back to enums. Okay, so this is command uppercase, and then it's this syntax here. So if it's command, if it's this, it's going to. Why is Rust Analyzer just not working? Should know what that is. Rust tone string to uppercase. Oh, that's a very big screen. Really? So I need to, okay. Output dot. Oh, why is the analyzer not working, man? What's going on with you? Is it this? Like it's not working here either, is it? Oh, come on, bro. Cargo install. No. C list, C brave, quiz 2. Oh, what is going on here? How are we doing on the stream side? You guys bored? Still got 2 viewers on Twitch. 1 viewer, which I suspect is me on YouTube. Alright, fair enough. Not even a cup of tea. Just going through Rustlings right now. Yeah, trying to figure out a couple of stuff. Also, why Rust Analyzer not working in Rustlings. Do I want to work on the repo? Oh god, that's a really big issue. You need to set, in order to configure Rustlings has an unusual project structure. Okay. Okay, Rustlings LSP. Determine the toolchain. Okay, Rustlings watch. Here. Hopefully I can just restart. Oh, come on, bro. Why is it being so special? Okay, good. It's working. Ah, okay. Now we can get some nice stuff. So output dot append the string. Actually, we can do output dot append the result of the match. Or actually, just let transformed string equals that, and then we can do output dot append the transformed string. Whew. Man, I felt so like suffocated by coding without an LSP. Maybe I kind of make fun of people who can't program without a copilot, but I feel like I'm so reliant on the LSB because, but it's tooling, you know, it's tooling. It's fine. This returns other. No, sorry. String dot a mutable vector string. Oh, that one. Really? At 0. This is a mutable vector a string. Interesting. What do we need to import to have transformer in the scope? Actually, I kind of wonder that. That's not super sure about this. Also, what do they use? I don't. Wait. You want a vector? Oh, right. I got you because you want multiple strings, not just Okay, just misunderstood the question. Okay, now we can do dot iterator. Okay, what are the methods we have? Dot, yep, we have a bunch of methods. We have a bunch of more methods. We have even more methods. I got so many. So many, that's crazy. 2 uppercase. There we are. That's what I was looking for. To trim. So it's just string.trim. String.trim. Can I return to string slice with leading trailing dot cloud? Yep. So yeah, so I need to kind of clone and then do a trim dot clone dot trim dot to owned. I could probably do it without the clone. So we trim it and we do to owned. Create owned data that from borrowed data, usually by cloning. Yeah. And we should clone. Actually go to owned dot, but trim will, yeah, we won't return the thing. So we can clone, then we can trim, and then we can go to owned, which kind of makes sense. We clone the original command, we trim it, then we go to owned. String dot a string plus append bar. I think this should work. This one I don't know. I actually don't know what it wants, so let's see what Reddit says. What do you need to... Oh, is it use super my module? Transformer. This. Oh god. That's no good, is it? Let's just clear. If we save. Oh wow, yeah, that's a lot of stuff. Mm-hmm. Expect a string found vector of strings. Oh. The Rust analyzer is not complaining. Love that. Yep. Plus cannot be used to concatenate two strings. String dot to owned. I think if I skip the hold on, I'm trying to do this in one line, which maybe isn't. Owned string equals that. We do this. Oh, I forget I'm not getting any formatting. Need to set that up. Own string dot trim and own string. Yep, that's good. What else do we have? We're appending transform string. Expected immutable vector of string. I don't understand what this is. Do I not need this or something? Pretty confused. Okay. Expected. Oh, not append, it's push, isn't it? Okay. Okay. So I mean we're doing a trim. Returns a string with leading and trailing paths removed. Interesting. So how to return? No, just like that. That's pretty weird, isn't it? We do it to owned. We do a trim. And then it's not transformed. Do a different function. Dot trim returns a slice. Yeah. I mean, surely, right? Trim, it returns a pointer to a string. Is this one of those weird things where I can do own string dot to owned again and it works? Yeah, it is. So, how does this work? The own string returns a full string object. The trim returns the pointer to the string. Or the pointer to a string. So it doesn't mutate the string. Yeah, so if I do mutable here, then I change that like this. Okay. Yeah, that kind of. Then we can trim it in place and go that to owned again. That would work now. But hold on. Compiler gave me some really good advice. Match arms having compatible type. I mean, might as well do this, to be honest. Dot trim dot to owned. Seems like sorry. What else do we have? So the append takes in a use size. times. I mean, this just looks like a let's appending string equals that, and this is a mutable pointer. So we get full Rust range syntax, range expression dot dot, so for in 0 dot dot times appending string dot let's push. Push. Can I do bar? Kind of spread. I wonder if that works. And then go appending string dot to owned. Expected char. Rust mutate string. Append. How do I concatenate strings? Push underscore stra. Append given slice to the end of the string. Yeah. Oh. What do I do here? That's a pointer to a use size. Rust expected int found pointer to a use size. Do I need to do something different here, like mutable times and then times? Oh, okay, what's different here? So if I take in a pointer to a use size, I'm responsible for it? Mutable use size? No. Hint. No hints this time. Yeah. What is it talking about here? What did the other guy do? Oh, what? You can do string from string, count the use size. What? Rust point? No, it's not a point. It's a reference to use size to use size. What's the automatic way to do this? This star. That I just need to do star there. Weird. Okay. I think we're going to have to try and understand this a little bit better. Yeah. Because don't really understand what's going on there. To be honest. Anything in chat? No one's in chat, everyone's very quiet. Just a read from earlier. Alright. Cool. Let's check out the viewers. Oh, actually, they're all here. Got one on Twitch, which I strongly suspect it's me. One on YouTube, which again I strongly suspect that it's me. That's okay. Okay. Understanding ownership. We're gonna have to get this, guys. We're gonna have to understand this. Okay. We have scope. We have variable scope. So, okay. We have a string type. Okay. Oh, actually, method syntax. Did I touch this? Or yeah. Wait, hold on. We'll discuss syntax more in method. Yeah. Okay. This kind of string can be mutated if we put mut before. Okay. Yeah, I remember understanding this. I need to kind of get what's happening when it's passed too. For example, this takes ownership of S. That one makes copy. Yeah, because that's more complicated. This is very trivial. Okay, but what about the pointers? References and borrowing. Oh, is it because it was a borrowed value? That was the concept. Okay. So S is a pointer to S1. Sorry, a reference to S1. Because this is borrowed value. I do not have final say over it, right? I don't actually get to say what it is. And I guess the same for these enum types, maybe. Okay. S is a reference to a string. This doesn't compile. Okay. The error that it gives me, something string is an add to reference that data it refers to cannot be borrowed as mutable. So, oh yeah, we're mutating it, so that's not gonna fly. Okay. Mutable references. Yeah, we can only have one mutable reference. That was the rule. Okay. Okay, getting there slowly. Okay. Want to keep going. Primitive types. 1. Div types. So let's go 1, 2, 3, 4, 5, 6. Okay, what do we want? Let is evening equals true. Sure. Okay. Okay. If it is alphabetical, numerical, finish line like the example. So like your character equals 2. Okay. Oh, this is I can't remember. Is it vec 1, 2, 3, 4 nd? Tell me what type it is. Vector of I32s. Meh, I eat always like that for breakfast. Okay, so is it like, oh, I can't remember. Rust learning book. Here. I need a race. Give me a race. The array type. There it is. So 5, 1000. That was it. Yeah. So that just yeah, this one just says that I need 1000 fives. Okay. Nice slice. So this is going to do get a slice out of array of where. Okay. What is this? Do I need to do like a dot filter? Unfortunately, users are currently not always optimized, as they could be mainly concerned large arrays. Mapping over small arrays seems to be optimized just fine. I can't remember. Let's actually do hint. TikTok understanding shape slice other slices. Yeah, this one. Got you. The slices type. I mean, I don't know what it wants me to do, to be honest. 0.4. Wait, why can't I just go 2, 3, 4? Get a slice out of array. A where summing. Hold on. Rustlings answers. Rustling solutions kept up to date. So exercises, the primitive types. Which one am I on? 4. Oh, pointer from A. So we go like from A between 1 and 4. That's it, yeah. Yeah. Why can't I do this? Doesn't have a known size compile time. So I need to point to the array. No, borrow the array. Okay. Slowly understanding it. So we need to do name, age, and you can go as well. Place with a tuple indexing second. What is this? Use a tuple index to access the second element of numbers. Okay, so numbers dot 2. Or is it first technically? Yeah. Okay. Ooh, vectors. 1, 2. Oh, sorry. Okay. Your task is to create a vector which holds the exact same elements as an array A. Okay. I mean, yeah, but is that the solution? That doesn't seem like the solution. Oh, it is a solution. Okay. Okay. What is this? A vector of even numbers is given. Your task is to complete the loop so that each number in the vector is multiplied by 2. Okay. So we get the iterator of the reference to vectors. So we borrow the value. This is a read-only borrowing. Yep. Yeah. This is not the transfer of ownership or anything. We do the iterate, we map the element. And we can go. You can just return the new number, which is going to be vec_loop of element. I think. No, it's not. No, it's not. This is yeah, this is not what I want. So this is going to be element times 2, and then it collects them all. Fill this up so that each element in vector is multiplied by 2. Ooh, can I go element equals? No. Times or equal to? Cannot mutate a mutable object. Not mutable element. But I think this is this doesn't give me what I want. Yeah, it's not. So it does not iterate to element index. Doesn't know it. This index? Maybe? The iterate yields all items from start to finish? No. Ah, so it's gonna be that's a reference to immutable, so it's going to be element times or equal to. That should work, yeah. Okay, vex1. Nice. Okay. 30% there. Oh, actually. Okay, one more. I want to get this one. Because this is the moving stuff, and I'm actually kind of curious to how this works. Okay, so we want to fill in a vector. We say that vector is equal to vector for some reason. We do vectors out to push. So actually we want to have mutable. Is it mute to the vector? Let mutable vector equals that. That's it. Yeah, we have to define it's mutable. It returns this, and it passes. So it passes ownership down to here. If I didn't return it, it would disappear and be not garbage collected, but freed, right? Okay. See next. Okay. Make the test pass by finding a way to keep both vectors separate. So this goes ahead and pushes returns, and yeah, they're separate. So how do I get it? How do I get it to return a copy? So I can do this. No. I can get a reference to it. Can I? I'll just do that clone. Is that the right solution? Hold on. That doesn't seem quite right to me. Okay, you can pass a reference to it and clone further down. So I guess that looks cleaner. Pass a reference, and then this is a reference to vector, and then call this clone, like so. Yeah, it's a little bit better. Okay. Make me compile without adding new lines, just changing existing line, no lines with multiple semicolons necessary. Okay. So we want to just say, ooh, I don't know. Is that it? We say mutable vector. And we push vector 1. So before, so okay, we're getting a mutable vector, we're pushing, we're sending back, so vector 1 is going to be that. Yeah, cool. Okay, refactor this code so that instead of passing vector 0 into the fillVect function, the vector gets created in the function itself and passed back to the main function. Okay. Let's create and fill the vector in here. So I mean, let's just take that and then delete that. Yeah, I mean that's it. Is that it? Yeah, I mean they did that. I just, yeah, why push so many times? Okay, make me compile only by reordering the lines, but without adding or any of them. Okay, let's read what we have so far. Without, okay, just gonna full screen so I don't get tempted to look at the right side. We have a mutable pointer to x, which is 100. Is that even valid? Like to start with, I don't think you can have a mutable pointer to this. Maybe you can. Okay, so that seems pretty independent. Mutable pointer to x. You can't have two mutable pointers at once. You can't have two mutable pointers at once. So is this just about doing this? Doesn't seem right. Really? I'm so confused why this works now, actually. Because we still have two mutable references now. This is a ChatGPT question. Let's go with Gemini. Let's see what it wants. I'm struggling to understand why this Rust code works, but this one doesn't. Let's see if it gets it right. Okay, a difference in behavior occurs in the main function. Here define and create two mutable references to the same underlying memory location and X stored, modifying Y and Z essentially modifies the same value. Why doesn't work? In a non-working code you're attempting to... No, that's really not what I'm asking. But why does this reordering of lines make it work? Yeah, because like you're still then asking. Personality doesn't matter. What? That's so weird. Rustlings, answers, explained. Rustlings, move, semantics, 5, explanation. Okay. Okay, yep. Yep. I mean, I understand we can't have two mutable pointers the same. Make me compile. We cannot have two mutable references within the same scope if we ensure that Y and Z do not share the same scope. We will only have one mutable reference at a time. Okay, since Y is not referenced in the code. Oh, it's only if... that's really smart actually by the compiler. So if I went and said like the pointer to Y plus or equal 2, then this doesn't compile. Right, because this is in scope. It only sees below, almost. Like, doesn't see the stuff above. Like for Z is very happy here. Wow, that's really clever compiler. Wow, so really cool. Yeah, crazy. All right, 6. We can't change anything except adding or removing references. So we have date, Rust is great, choose string. Okay, we got char data. Surely I need to should not take ownership, so it borrows. Okay. String uppercase should take ownership, so you go here and say this. Okay. What's that about? Oh, it actually does take ownership, like so. Immutable data. So yeah, we allow the parameter to be mutated, so that we can then do this. Okay, and this is now structs, but call it a day. Nothing quick stream. Yeah, guys. I mean, thanks so much for watching. Oh, I kind of want to end tmux show clock. What is this? Show the current time in tmux pane. Can't remember what it was. Prefix T. That's it. Time. There we are. So time is 11:24 for me. I have work in the morning. Gotta get up somewhat early. But it's really fun. I really enjoyed doing this Rust stuff, and the ownership and reference stuff I think is really starting to kick in. So I'm very happy about that, and I mean, super excited about it. This Rustlings thing is really cool. Hope to get all the way through it. I mean, we did the easy stuff today. We'll do the hard stuff maybe tomorrow if I have some time in the evening. Yeah, guys, thank you so much for watching. Those that have tuned in. Thanks for Rio for chatting with me, and Rohit, he chatted on the chat for a bit. Yeah,